So this is section 10.1, and we're talking about parabola. Or sorry, 10.2. We're actually starting at 10.2. We're skipping the first section, chapter 10. So 10.1. All of this is about conic. Chapter 10. This first part of chapter 10 is all about conic sections, and today we're talking specifically about parabolas. So when we say conic section, we're talking about parabolas and conic sections. We might wonder, what does a parabola have to do with a cone? So let me pull a picture up here, and I will go away. And we'll talk a little bit about why we call these conic sections. So here's my picture. Turns out that if we cut a cone, so this is a cone. If we cut a cone with a plane parallel to one of the sides of the cone, we end up with a parabola. So that's why we call it a conic section. And all the shapes that we'll talk about in chapter 10 turn out that if you cut a cone in a specific way, you get that particular shape. So this is really where people first started working with parabolas. Is the Greeks figured out that if you cut a cone this way, you end up with this shape that's a parabola. It took a long time before we figured out the parabola was a graph of some kind of quadratic function. So all of these shapes that we'll talk about in chapter 10 are conic sections. So this is a picture of the cone being cut by a plane and giving us a parabola. And we've talked about parabolas, graphs of parabolas, when we talked about quadratic functions. We're going to talk about parabolas in a little bit different way today. We're going to get a little more basic about parabolas. So we're going to give a definition of a parabola. Rather than saying we have a quadratic function or something like that, we're going to be a little more basic with our definition. So a parabola. Parabola is the set of all points and we're in a plane. So we're talking about the set of all points in a plane that are the same distance from a line, and we call the line the directrix. And a point called the focus. So this is our definition of a parabola. It comes from a conic section, comes from cutting a cone with a plane. But this is our definition. What this means is, if I draw a picture of a parabola here, so just a little sketch. We know that a parabola is kind of a U shape. So here's my x and my y axis. We'll do a simple parabola. And here's my parabola. So we know that that's what a graph looks like. We have a point inside the parabola called the focus. And we'll talk a little later about why we call it the focus. And we have this line down below here like so. we have this line underneath the parabola. This is our directrix. And our vertex is right here. What this definition tells us is that if I have a point here on the parabola, so here's my point on the parabola, and I draw a line from the focus to that point, and I draw a line straight down to the directrix, the lengths of those two segments are the same. So if we call this D1, the length of that segment, and we call this D2, D1 equals D2, anywhere on the parabola. No matter where I put that point, if I draw a segment to the focus and a segment straight to the directrix, the two distances, the lengths of those two segments are equal. So that's how we're going to define our parabola. So it's pretty interesting. It's a really cool thing with parabolas that you get. It comes from cutting this cone. We can define it in this way, having to do with this point called the focus and this line called the directrix. We can define it this way, and we end up with something like y equals x squared. So all three of those are different ways of looking at parabolas, but they all tell us about the same thing. So we're going to be doing a lot of work with the focus and the directrix to figure out things about a parabola if we know about the focus and the directrix. This is what we're talking about. Focus always inside the parabola. The directrix is always outside the parabola. The vertex is between the focus and the directrix, and we'll get into more about that in just a second. All right. So any questions about this definition? All right, so let's talk about how we're going to work with this idea, with the focus and the directrix and our parabola. So in the past, we've worked with a vertex form of a parabola. We've used completing the square to define the vertex of our parabola, and we've done some work with that. So we know that the vertex form of a parabola, just to review a little bit, or as a reminder, our vertex form of a parabola is y equals ax minus h squared plus k. And our vertex is at the point h, k. So we did some work with this before in this class. What we're going to work with now is the standard form of a parabola. And we're going to write out how that works. So the standard form. So we're going to go from our idea of a focus and a directrix and come up with our standard form. It's related to the vertex form, it's just a little different. And we're going to break it down into two different cases. So our first case is if our axis is vertical. So our parabola is opening up or down. So we have a vertical axis. So our vertical axis, our standard form for the equation is going to be x minus h squared equals 4p, this number p, y minus k. And for our vertical axis, the way we know that our axis is vertical is x, the x part is squared. So when we have a vertical axis, x is squared. So that's going to tell us it opens up or opens down. When we have a vertical axis, this is our standard form. Our vertex is at the point HK, just like it was in vertex form. Our focus is at the point HK plus P. So P is telling us how far away the focus is from the vertex. That's what this letter P tells us, how far the focus is away from the vertex. Our directrix is going to be the line y equals k minus p. So P tells us how far the focus is away from the vertex, and P tells us how far the focus is, or the directrix is, from the vertex. And we'll draw a couple pictures here in just a second. If P is greater than 0, so P is positive. P is greater than 0, everything's positive, our parabola opens up. If P is negative, P is less than 0, our parabola opens down. So if we have a negative number here, our parabola opens down. And if our vertex is at 0, 0, then our standard equation is just x squared equals 4py. So this is all of our information about our standard form. So let's draw a couple of pictures here. So we'll draw one for our parabola opening up and one for our parabola opening down. So there's our x and y. And here's our parabola. I'll draw that in red. And we'll draw our directrix in red. So here's our directrix down here below. And here's our focus. So the vertex is at the point HK. So whatever the coordinates, that's HK. Our focus is always inside the parabola. So this is going to be at the point HK plus P. P tells us how far I move up from the focus to get to the, or up from the vertex to get to the focus. And the line here, the equation of this line is y equals k minus p. So I'm going up p units to get to the focus and down p units to get to the directrix. So this distance here is p, and this distance here is also p. And this is for p is greater than 0. So our parabola is opening up. And it's the same picture, just opening downwards if p is less than 0. So I'm just going to draw the parabola here, and we'll draw in the focus and the directrix. So p is less than 0, our parabola opens down. Our focus always inside the parabola. And our directrix is going to be up here. So this is for p is less than 0. We're still at the point HK for our vertex. And this is still p units. And we're still going p units. So if our parabola opens down, we figure out where our vertex is. We go down by p units to find our focus, and we go up by p units to find our directrix. So the reason, the thing that we use the p for here in our equation is to figure out how far, basically to figure out how far our focus is away from our vertex and how far our directrix is away from our vertex as well. So any questions on our vertical axis parabolas with our standard form? Now what we're going to do with this standard form here is we're going to figure out how to use, if we're given some information about the focus or the directrix, that kind of thing, how do we write the equation of a parabola if we know some information about the focus and the directrix? All right, so let's look at how this works with a horizontal axis, if our parabola opens left or right, and then we'll solve some problems using this idea. All right, so a horizontal axis, basically what happens with a horizontal axis is x and y just switch places. So the way we know that we have a horizontal axis is if y is squared. So if the y part is squared, we have a horizontal axis. So our equation, our standard form, is going to be y minus k squared equals 4p x minus h. And again, our vertex is at the point hk. Our focus, since our axis is horizontal, we're going to move left and right from our vertex to find our focus and our directrix. So our focus is going to be h plus p, comma k. So we're moving to the left or to the right. Our directrix is going to be the line x equals h minus p. So we move to the left or to the right to get to the focus or to get to the directrix from the vertex. Our axis is y equals k. And let's go back here really quickly on our vertical axis. The axis of our parabola for a vertical axis is x equals h. So our axis is going to go straight through the vertex and through the focus. All right, so our axis here is y equals k. If p is greater than 0, p is positive, our parabola opens right. If p is less than 0, our parabola opens left. And if our vertex at 0, 0, then our equation is y squared equals 4px. So again, p is telling us how far we're moving from our vertex to get to our focus and to get to our directrix. So let's draw a couple of pictures of our horizontal axis parabolas. So here's one opening to the right. The focus is always inside the parabola. Our directrix is going to be here. And this is for p greater than 0. We're opening to the right. Our vertex is still at the point hk. We're moving to the right from our vertex to get to our focus. So this is going to be at the point h plus p. Okay. And this line is x equals h minus p. So I'm moving to the left of my focus to get to my directrix. And our axis goes straight through the vertex and the focus. And if our parabola opens the other direction, if p is less than 0, things are just switched around. Our vertex is still at h. Okay. Our directrix is now on the other, our focus is inside our parabola, always inside. Our directrix is just on the other side of the parabola now, over here. And we're moving over p units to get to the focus and to get to the directrix. So this is for p less than 0. So there's all of our information about our standard form and our focus and our directrix. Now we're going to use this information to solve problems, to come up with equations, to figure some things out about parabolas. And we will, when we talk about ellipses and when we talk about hyperbolas, we'll do the same thing. We'll come up with a definition, and we'll use that definition to come up with equations and figure out what our ellipse, what our different shapes look like. All right. So any questions about what we've done here?
What does p equal 0?
If p equals 0, then we don't have an ellipse or a parabola. This whole side would be 0, and we just have y squared equals 0. So then, if y squared is 0, then y has to be 0, so then we just have a point. All right. So let's take a look at we're going to go through, I have 4 examples that I want to work through using this idea of the focus, the directrix, and the standard form for our equation. So our first example, we want to find the vertex, focus, and directrix. So we want to find the vertex, focus, and directrix, and we have y equals 1/2 x squared. So we know a couple of things right away. Because x is squared, is this going to be vertical or horizontal? X squared is, because x is squared, it's vertical. So we know we have a vertical parabola. We have y equals 1/2 x squared. So everything's positive, so does it open up or open down? Oh, p is greater than 0. Everything's positive, so we know it opens up. And because we're vertical, it opens up. We know that the focus is up from the vertex. So we know this. We know all of these things right away. It's vertical. The parabola is vertical. We know it opens up, and the focus is going to be up from the vertex. The focus is inside the parabola. So I'm going to rearrange this into standard form. In standard form, let's go back here really quickly. In standard form, we have the x squared part by itself and everything else with the y part. So let's get the x squared part by itself. So I'm going to multiply both sides by 2. I get x squared, sorry, 2x squared. X squared equals, going backwards, x squared equals 2y. So this is my standard form. The x squared part is by itself, and the numbers are with the y. The number that's here in front of the y is 4p. So 4p equals 2. Divide by 4, so p equals 1/2. So looking at this equation, where is our vertex? What's h and k in this equation? What do you think, Harrison? What are we adding? What are we adding here to? What are we adding here to y? 0. What are we adding here to the x? 0. So h and k are 0. This is, each of those is 0. So our vertex is at 0, 0. And if we look back at our standard form, if our vertex is at 0, 0, our equation is going to look like this. X squared equals 4p times y. There's nothing added anywhere here. So our vertex is at 0, 0. Our focus is going to be up from the vertex. So we're going to move up 1/2 unit, p units up from the vertex. So the focus is up 1/2 unit from the vertex. So the focus is at if I move 1/2 unit up, it's just going to be 0, 1/2. The directrix is going to be 1 unit down, or 1/2 unit down from the vertex. So the P tells us how far we move inside the parabola to get to the focus, and outside the parabola, outside the vertex, to get the directrix. So our directrix is at 0, or sorry, the equation is y equals negative 1/2. The directrix is a line. So if we drew a quick sketch of this parabola, there's my x and my y. My vertex is at 0, 0. It opens up. The focus is going to be at 0, 1/2. And the directrix is this line down here at y equals negative 1/2. So that would be a quick sketch of that parabola. So again, P in our equation tells us how far we're moving away from the vertex in one direction to get to the focus, and the other direction to get to the directrix. All right, let's look at another example. We want to find the equation, the standard form of the equation. And our parabola has a vertex. Vertex at 0, 0. And the focus at 0, negative 2. So from this information we can start a quick sketch already. So if I draw a quick sketch of my parabola, my vertex is at 0, 0, and my focus is at 0, -2. So which way does my parabola open? Has to open down. The focus is always inside the parabola. So my parabola opens down. So we know that already. This tells us it opens down. So without doing anything, we know that this opens down. And we know that our standard form of our equation is x minus h squared equals 4p y minus k. Well, since our vertex is at 0, 0, I know that my equation is going to look like x squared equals 4py. And we said that the focus is p units away from the vertex. So how far am I moving from the vertex? How many units down am I moving from the vertex to get to the focus? Our focus is at 0, -2, and our vertex is at 0, 0. So I'm moving 2 units down. So the focus is 2 units down, so P is 2. And the sign on P is going to be positive or negative. Since our parabola opens down, P is going to be negative. So my equation is going to be x squared equals -8y would be my standard equation. So because my parabola opens down, I know that P has to be negative. My focus is 2 units away from my vertex, and I'm moving down by 2 units. So x squared equals -8y. Now if this problem had asked us to sketch my parabola, to make a sketch, and we wanted additional points. So we know that our vertex is at 0, 0. We know that our focus is at 0, -2. There's a nice, once we know P, there's a nice way to find additional points on our parabola. If we go from the focus and we go to 2p units to the left or right, I'm going to go straight to the left to here and straight to the right onto my parabola by 2p units. And I'm just looking at the absolute value of p. So if I move over by 2 times 2 is 4 units from 0, I get a point at -2, 4. So I'm just moving over 4 units from the focus this way and 4 units to the left. So I'm going to be at a point -2, -4. So to find additional points on my parabola, I just go from the focus 2p units to the left and 2p units to the right, and I have additional points on my parabola. So again, just to re-emphasize, P tells us how far I move from the vertex to get to the focus, or how far I move from the directrix to get to the vertex. That's what the P tells us in this equation. H and K tell us our vertex. The P tells us how far we're moving from the vertex to get to the focus. Questions on that example? Question here? I switched my coordinates around, didn't I? Yes. So I did these backwards. This would be 4, -2. I just wrote them backwards. So the x is 4, we're going down 2. So I wrote these backwards. And this would be -4, -2. Thank you. So I just wrote them in the wrong order. All right, thank you. Let's look at another example. So these are two of the types of problems that you're going to be solving with parabolas. We're going to have an equation that's going to ask you to find the vertex and the directrix, or the focus and the directrix. It'll give you the vertex and the focus. It'll ask you to find the equation. It'll give you the directrix and the focus and ask you to find the equation. So there's lots of different combinations of types of problems that we're going to be looking at here. All right, let's look at another example where we have to do a little more work. We want the vertex, the focus, and the directrix of the parabola given by this equation. We have x squared minus 2x minus 16y minus 31 equals 0. So we want the vertex, the focus, and the directrix of this parabola. So this involves one of our favorite things. When we have a problem like this, when we have an x squared and x, we have all this, our equation written out like this. What you should think when you see this problem is complete the square. We have to complete the square. So the first thing I'm going to do, in our standard form, the x part is on one side, and the y, everything with the y is on the other side. So I'm going to rewrite my equation with all the x's on one side and all the y's on the other side. So I'm going to rewrite this as x squared minus 2x equals, and I'm going to add 16y and 31 to both sides. So that equals 16y plus 31. I'm just adding 16y and 31 to both sides of my equation. Now I'm going to complete the square on the x part. The x is the part that's squared, so I'm going to complete the square. X squared minus 2x. B here is -2. So let me write that here. B equals -2. We add b over 2 squared to both sides. -2 over 2 is -1. -1 squared is 1. So I'm going to add 1. This is b over 2 squared. Equals 16y plus 31. I added 1 here. I need to add 1 there so that my equation stays the same. This is now a perfect square. I can factor this. This is x minus 1 squared equals, and I'm going to write this is 16y plus 32. And in my standard form, I don't have any number multiplying the y. I have the number outside of the parentheses. So I'm going to write this y minus 1 squared. I'm going to factor out the 16. 16y plus 2. So here is my standard form of my equation. There's standard form. So looking at the standard form here, what do we know? Where do we know the vertex is? What do you think, Dominic?
Yeah, you're at
H and K?
Yeah. H be -4.
let's look back at what we wrote. So we know we have a vertical axis. It's x minus h, and h is positive. So it would be not -1, but just 1. So our vertex is at 1, -2. So it's just like we did before when we were working with vertex form. We changed the signs on these to get to our vertex. So our vertex is at 1, -2. To figure out where the focus and the directrix are, we need P. We have 16 here. The number that's in front of the parentheses is 4P. So 4P equals 16. So P equals 4. So our focus, I just divided both sides of the equation here by 4. So P equals 4. Our focus is 4 units. Now is this parabola opening up or down? Up. Opens up. X is squared, so we know it's a vertical axis. This is positive, so we know it opens up. So my focus is going to be 4 units up from the vertex. So what point is up 4 units from 1, -2? I add 4 to the y part. I'm moving up 4, so I get the point 1, 2. The directrix is 4 units down from the vertex. So what line, our directrix is going to be y equals. If I move down 4 units from -2, I get -6. So my directrix is y equals -6. So if I sketch a quick picture of this parabola, my vertex is at 1, -2. It opens up. My focus is at the point 1, 2. My directrix is this line, y equals -6. And if I wanted additional points, I can go over 2p units from the focus to the left and the right. So 2p is 8. So if I move over 8 units from 1, 2, I'm going to be at the point, I move over 8, so I'm going to be at the point 9, 2. And I move 8 units this way, and I'm going to be at -8. Sorry, not -8, -7. So those would be 2 additional points on my parabola. Move 2p units to the left and 2p units to the right from the focus. Questions on that example? So when the problem gives you this equation and it wants to focus the directrix and the vertex, that's telling you complete the square. Once we complete the square, we can write our equation in standard form. All right, so let's look at another example. Another kind of problem that you'll have to solve with parabolas. All right, our parabola has a focus at 1, 2. and a directrix at x equals 3. We want the equation. So we have a parabola, our focus is 1, 2, our directrix is x equals 3. So let's start out, for this kind of problem, I suggest you start out by drawing a little sketch. The focus is at the point 1, 2. The directrix is the line x equals 3. So is this parabola going to open left or right? Has to open left. The focus is inside the parabola, so we know that it opens left. So we know already that our parabola is going to look like this. So since we know it opens left, what is going to be squared, x or y? Opens left, so y is squared. And because it opens left, is p going to be positive or negative? P is less than 0. It opens left, so p is less than 0. So all of this we know without even doing any math. All we did was draw a little picture. We know that y is squared, p is negative, it opens left. So we've done a lot of work. We've done a lot of work already. For a parabola, the vertex, if we look back at what we said about our definition, let's look back, and we'll look at the one here. It's p units from the vertex to the focus, and it's p units from the vertex to the directrix. The vertex is halfway between the focus and the directrix. The vertex is right in the middle of the focus and the directrix. So we can figure out where the vertex is on this parabola. The vertex halfway between focus and directrix. So we're looking for this point that's halfway between 1, 2, and halfway between 1, 2 and the line x equals 3. So we know, what do we know that the y coordinate of the vertex has to be? We're looking at this picture, what's the y coordinate? How far are we moving up to get to the vertex? 2. It has to be on the same, our axis, the vertex and the focus are on the same line. So y has to be 2. So our vertex, we already know it has to be something comma 2. What point is halfway between 1 and 3? What number is halfway between 1 and 3? What is it? 2. 2 is halfway between 1 and 3. And if you can't remember, if you couldn't figure it out really quickly, add 1 plus 3 and divide by 2. 1 plus 3 is 4, divided by 2 is 2. So the vertex has to be at the point 2, 2. And so this vertex is at the point 2, 2. Well, from this, what does this tell us? If p is a distance from the vertex to the focus, what is p? How far am I moving to the left to get from the point 2, 2 to 1, 2? How many units? How much does x change here? Negative 1. So p has to be negative 1. So because I move 1 unit from the vertex to the focus, p has to be negative 1, and now we're set. Our equation is going to be y minus k, which is this coordinate in my vertex, y minus k squared, equals 4p 4 times negative 1 is negative 4 times x minus h, and I'm set. There's my equation for my parabola. Questions on that example? So again, P tells us how far the vertex is away from the focus, how far the vertex is away from the directrix. The vertex is halfway between the focus and the directrix. The focus is always inside the parabola. All right, I have one last example today. Another kind of problem that you're going to have to solve with parabolas. So we have a parabola. It has a vertical axis. Parabola has a vertical axis. It goes through the point negative 3, negative 3. And the vertex is at 0, 0. So let's figure out the things we know right away. Vertical axis is x or y squared. X is squared. Our axis is vertical, so our parabola opens up or down. So x is squared. Our vertex is at 0, 0, so we know that our equation is going to be x squared equals 4py. So what we need to figure out here is p. Anybody have an idea how we're going to figure out p from what we have here? Plug in the points. We have 2 points. We have an x and a y here. So we're going to plug in the points. So I'm going to plug in my x. X is negative 3. So I'm going to plug in negative 3 squared equals 4p times y is 3. And I'm just going to solve for p. So 9 equals 3 times 4 is 12. 9 equals 12p. And I divide by 12. And p equals 9/12. And I can reduce 9/12 to 3/4. And now I'm going to plug that back in here. So my equation is x squared equals 4 times 3/4 y. 4 times 3/4 is just 3. So finally, my equation is x squared equals 3y. Questions on that example? All right, so the big things from today. P in this equation tells us how far the focus is from the vertex, how far the directrix is from the vertex. Focus is always inside our parabola. Directrix is always outside our parabola. Vertex is halfway between the focus and the directrix. So we're done with examples. I just wanted to talk really quickly about, we talked about the focus. One reason that we call the focus is if we have a lens or a mirror. So if I have a mirror that's the shape of a parabola, any light that comes in parallel to the axis reflects to the focus. So if I have a parabolic mirror, if light comes in parallel, it all reflects to the focus. So this is how telescopes with mirrors work. The mirror is parabolic. The light that's coming from the stars is just about parallel, and it all goes to the focus, so we can focus the light on at that point. This is also how the lens of a flashlight is designed. The bulb is at the focus, so all the light that comes from the bulb bounces off the reflector in your flashlight and comes out in a parallel beam. So the focus is, we can think of it as focusing all of those beams at one point. All right, I know that was long. It's a lot of information to talk about. Homework. Page 712, 1 through 10, 13 through 35, every other option.